calculate the energy between them. Where there is lowest energy, there they say, okay, this could be the best binding site.
Right.
And since you get hundreds of thousands of values, so there is always one algorithm inside, and mostly it is genetic algorithm in all the docking softwares, which basically sort list by using some kind of uh, iteration, like they run the cycles. Okay, we need to change this, we need to go for some approximation, something like this. Then okay, this is the value, so they just pick the best value. Okay,
Yeah.
and then they say this is the binding site. So here also you need some kind of algorithm implementation, and you might see more or less more than 100 softwares available for docking. There are many freely available softwares as well as paid softwares available, commercial softwares. Most of the companies, pharmaceutical companies, are using paid softwares. But in academia, mostly we are using free softwares, or we try to develop our own tools for such purpose, because the academia cannot buy such an expensive tools or softwares every time. But for the industry, since they are associated with directly developing the drugs which deals with the human health, so they always need the best quality software. There are some of the tools, for example, called Vienna, Autodoc, Gold, something like, these are used, but there are so many softwares which we cannot name them every time without looking for the list. But Autodoc Vienna is the most commonly used software. Okay.
Yeah.
And here you will see many people are using. But depending on the type of auto docking, these tools should be used. Is it clear?
Yeah.
Now, yes, do you have any question?
No, no, no. Like recently, I took a course called like a computer-aided drug designing.
Mhm.
So I use those tool like Autodoc and Bina and some others as well.
Yes.
Yeah.
So there are some servers which you will learn during this training period, where like you will need to prepare all the input files and then go for uploading the files, choose the parameters, and then just you will not know which software has been used. Of course, there are some parameters which you can change, and then you will know if you will play with the parameters, then you will know if this software is using Autodoc or some other tools. But there are some direct softwares also which are directly using their own way of calculating the binding affinities. What I always prefer, whatever the softwares you are going to use, before using these softwares, you must need to know the working principle of the software instead of just executing the software. And more than 90% people make such mistakes. Then when you are submitting the manuscript, you get some questions from the reviewers, which you are not able to answer in professional way.
Yeah.
So it is always good that you need to know the working principle of each and every software before you use. Now, this is like, first part of today's introductory class. Next part is, as we have some earlier discussion with you about coding. In coding, you need to understand the logic. Instead of coding, you need to understand the logic of the coding. Okay.
Yeah.
And logic of the coding should be so much clear that you do not need to make any mistake. If there is some kind of mistakes that may happen in programming part, but not in logical part. It's always the people fail is in logic implementation. The logical implementation of any problem is mandatory to be clear. And the best way is to write it on a hard paper or a PPT slide. What is the main goal of your work or the project? Now I am going to give you one simple example. For example, I'm saying that there is a small system which is similar to a cell where there are 60 or 100 genes. And these 100 genes are connected with each other in equal ratio in a way of activation, deactivation, or no interaction. For activation, you are allowed to use 1 plus 1. For deactivation, -1. And where there is no interaction, that will be 0. So there are 100 genes. And you need to plot the matrix or generate the matrix for these 100 genes, where you will be printing on your screen 1, 0, and -1 in random way. So this is the first task. So what will you do here?
uh, I'll check the probability of their expression, right?
Yes. You can say clearly there is nothing to be shy or anything,
Yeah.
because you are just attending a class.
Yeah.
So if you will say something clearly what you understood
Yeah.
from my question, then it is just clear that, okay, you are saying this, then I will help you how to clarify or where are the mistakes. You just say what you understand.
So you're talking about how metrics work and how we will input it, and it will give our plotting results, right?
Yes. This is currently, I'm saying it is one network only.
Okay.
Yes. So you have to say now.
So as you showed yesterday, how we can make a matrix, and that we can just for a one matrix, then we can implement it for multiple network, right? To create a network.
Okay.
Yeah.
So first thing here, what you need to write on your notebook or in the PPT slide.
Mhm.
So my question was a cell with 100 genes,
Mhm.
100 genes
Mhm.
are connected. So a cell with 100 genes
Yeah.
all the genes are connected with each other, okay,
Yeah.
in equal ratio of +1, -1, and 0.
0.
Okay.
Yeah.
So +1 is activation, -1 is
Inactivation.
deactivation,
Yeah.
and 0, no interaction. Is it clear?
Yeah.
Now, first thing you need to think, I say equal ratio. So equal ratio means 33.33% will be +1, 33.33% will be -1, and the rest will be 0.
Yeah.
Is it right?
Yeah.
Yes. So what you see here, because you have 100 genes and I'm saying they are connected with each other, where you are also allowed to go for self-activation or self-deactivation. That means gene 1 can activate itself, or deactivate itself. Is it clear?
Yeah.
So here you will need few things. For example, first thing, how many genes you have? Number of genes? 100.
Yeah.
So the matrix size will be
100.
100 by 100,
100. Yeah.
because I'm saying with each other. That
Yeah.
means 100 by 100.
100.
So when I'm saying matrix size, that means row and column has 100 genes, okay,
Yeah.
in the same sequence. Okay. So
Yeah.
that means I will say I and J, row and column.
Hmm.
Is it clear?
Yes, bro.
Yes. So some people also write this thing in different way. For example, they write like this: I, comma, J. This is also how the people used to write the matrix. I
Yeah.
hope you are getting the things.
Yes.
Yes, yes. So this is called, so that means gene 1 to gene 100 will be in the like row, and gene 1 to gene 100 will be in the column.
Column.
Okay.
Yeah.
Yes. So this is first thing, number of genes. How many genes you have? Since you are saying that you will be looking for one gene interaction with the all other genes interaction. So here what will be the first requirement? That means the row. For example, I'm saying for I equal to 1 is to total number of genes. Is it clear?
Yeah.
And I means, let's say, row.
Hmm.
And then similarly, you will write another loop. Currently, I'm just saying looping. This is the first thing which you will start as a loop, that now you will enter into J, that is column,
Hmm.
or J equal to 1 is to number of genes.
Hmm.
Very clear?
Yeah.
That means I and J, row and column.
Yeah.
Now, without thinking anything, what you need to do, because in programming, if you start any loop, there is a need to end that loop. Okay.
Hmm.
And to end the loop, there are different way of writing. But for example, in MATLAB, you write directly end like this, end
And.
and end. Okay.
Hmm.
So that means you are saying, by the way, I'm doing some justification, something like this. So
Hmm.
it will be easier to understand.
Yeah.
Okay.
Yeah.
So the first end is to close this internal loop.
Hmm.
Second loop is to close this one.
Okay.